Section 1.3, compressed numbers. There is no real number solution of the equation. Remember that x squared equal to -1. If we want to solve your x, you're gonna take the square root for both sides. Alright? But when you take the square root, the right hand side here, that will be square root of -1. We say that if the root, the nth root of -1, if the n here is an even number, this guy has to be positive numbers. Otherwise, we're gonna say this is a no real solutions. But for these sessions, we're gonna start with the compressed number. What is a compressed number? When you see the square root of -1, we're gonna let it to the I. Okay? The I, this is called the compressed number. When you take the square for both sides here, you're gonna find it out. I squared is gonna be equal to -1. I want you guys to highlight this one. I is equal to square root of -1. And we call this is the compressed number. A and B are real numbers, and then any numbers of the form a plus bi is a compressed number. Okay, a plus bi. For a here, this is the real number. And then the b here, we call this is imaginary part. Okay, imaginary number. So when you see the form compressed number, it will be the a plus bi. Two compressed numbers, a plus bi and c plus di, are equal, provided that the real parts are equal and their imaginary parts are equal. That is. So if I have a two compressed number and they are equal to each other, then you can say a equal to c. The real part equal to the real part, a equal to c. And the imaginary part, b equal to the d, b equal to the d here. Okay, for the compressed number a plus bi, if b is equal to 0, the imaginary part is equal to 0, then we only have the a here. Then the set of real numbers is a subset of the set of compressed number. If a equal to 0, but b is not equal to 0, we're gonna say this compressed number is a pure imaginary number. Okay, pure imaginary number. Just you only have the I here. A pure imaginary number, or a number like 7 plus 2i with a not equal to 0 and b not equal to 0, we call this is non-real compressed number. Okay, non-real compressed number. And a plus bi, we call this is going to be the standard form. Okay, standard form of the compressed number, a plus bi. Okay, look at here. Remember we learned the natural numbers, the whole numbers in the previous sessions? Natural numbers, that is starting from 1, okay, not including the 0, all positive integers. Whole number will be including the 0, 0, 1, 2, 3, 4, 5. And then integers, it can be like all positive integers and all negative integers. This part means like including. And then rational numbers, that will be the integer over integer. Or you could have a decimal space with repeating last digit, or they do have an ending digit for the decimal. That will be the rational numbers, like 0.35, 0.75. That is, they do have an ending digit here, so that's a rational numbers. Irrational numbers, that will be the number not the rational. Okay, like the pi 3.1416, and then keep going on. Okay, and then real numbers. Real numbers, this is talking about we don't have the imaginary part. Okay, only a. This is all including from the real numbers here. Okay, non-real compressed number. Compressed number is gonna be another side. Okay, that will be involving like the I in here. Okay, expressions. if a greater than 0, then square root of negative a, we could rewrite it to I, and then square root of a. Okay, remember this is gonna be square root of negative 1 times a, and then square root of negative 1, which is gonna be equal to I. Okay, I need you guys to highlight this one. Okay, for example, this one, we could break it down like square root of negative 1 times square root of 16. And this guy, that will be equal to I. And what is the square root of 16? That will be equal to 4, right? So that will be 4I. Try to do B and C. Okay, B, same idea. We could break it down like square root of negative 1 and square root of 9. Right, and this is going to be your I. This is going to be your 3, right? So that will be 3I. C, I could break it down to negative 1 times 16 times 3 here. Okay, so this guy, that will be your I. Square root of 16, that will be equal to 4, right? And then we can't do anything for square root of 3. So we just keep the radical, square root of 3 here. So that will be negative, outside that's a negative, negative 4I times the root 3. Okay, what is going to be negative 4I square root of 3. Okay, operations on compressed number. Products or quotients with negative radicands are simplified by first rewriting square root of negative a as I square root of a for a positive number a, okay? Based on this guy has to be positive. Then the properties of root numbers and the fact that I squared equal to negative 1 are applied. When working with negative radicands, use the definition, okay? We want to use this definition before using any of the other rules for the radicals. Let me show you guys the example. We do have the rule like that, square root of c times square root of d. Since both of them, they are square root, so you could combine c and d together, make it like square root of c times d. Okay, and this is valid only when c and d are not both negative. Okay, these two guys cannot be negative. For the example, if I have a square root of negative 4 times square root of negative 9, the first thing, we don't want to apply this rule. Okay, we want to apply this definition first. Okay, make it like compressed number. So you do have a square root of negative 1, which is going to be your I, times square root of 4, which is going to be 2 here. Same idea with this guy. So 2I times 3I, that will be 6I squared. And remember what's the I squared equal to? I squared is equal to negative 1, right? So 6 times negative 1, which is going to be negative 6. If you work on the same questions again, but you don't want to apply the definition of compressed number, you will apply this rule first. What happened? So when you combine the square root together, the negative gonna be goes away, right? Because negative 4 times negative 9, which is gonna be 36. Square root of 36, that will be 6. So this is wrong, okay? Make sure this is not the correct one. Okay, every time when you see the negative radicand, you want to make it this definition. Okay, use this definition first. Okay, let's try. This is a square root of negative 21. So use the definition of compressed number first. So that will be I and then square root of 21. Same idea for this guy. Okay, I times I, that will be I squared. And then square root of 21 times square root of 21. So these two, I could cancel out the square with the square root. And then I squared, which is going to be -1. So final answer, -21. Okay, B, do the same thing. This is going to be I square root 5. And this one, that will be I square root of 30. Okay, now both of the radican are positive. So we could combine the square root together. And then I times I, which is going to be I squared. So how can you break it down with 150 with the square root? So you know 150, you can break it down like 25 times 6. Okay, right? So what is the square root of 25? That will be equal to 5, right? And I squared, which is going to be -1. Okay, two more. Try. Okay, do the same thing here. Use the definition of compressed number. So that will be I square root of 42. And this is I square root of 3. Now, both of the radicand is a positive numbers. So you could combine it together. What is a 42 divided by 3? And the I here, the compressed number, you could cancel out, okay? So that will be square root of 14. Okay, D. Check your work, combine it, simplify it. You're gonna get I square root 3. Okay, this one. Write this form in the standard form. Okay, write the complex number standard form a plus bi. So first, we're gonna take care of square root of -75 first. So that will become I square root of 75. Can you guys simplify this guy? Square root of 75, you can do 25 times 3, right? Okay, square root of 25, which is going to be 5i square root of 3. And then, hey, make sure you don't cancel like the 5 with the 15 or 5 with 5 here, because this is subtractions. What you're going to do, factor out the 5 before you simplify. Okay, I take out the 5 here, I left with the 3 minus I square root 3. And then now you can cancel because that's a multiplication here. So this is gonna be my standard form a plus bi. Okay, a plus bi. Addition and subtraction of complex number. When you have a two complex number, a plus bi and c plus di, you could just combine the real part. A and c are the real part, you could combine it together. And then b and d, that's the imaginary part, so combine it together. Same idea with the subtraction. Okay, you could just think about it just like combine the 9 terms. Okay, I and I, that's a 9 terms. Real number and real number, that's a 9 terms. So try. For part B, be careful the negative. Okay, you're gonna distribute the -1 for both of them. Okay, let's do together. I just group like the real numbers together and the imaginary number together. Okay, if you can handle it, you could just take care of it without writing like this way. So you should find -1 plus 3i. Okay, B. This is gonna be distributed negative. So -5 plus 3i. Negative, negative, you're gonna get the positive. So you should get -15 plus 10i. Okay, right? Addition and subtraction with the complex number. Okay, multiplication. You're gonna distribute it like one by one. You don't have to memorize this formula. Okay, just use the FOIL method. Distribute it like one by one here. Okay, so this one, I'm gonna use the FOIL method. 5 times 2 minus 5 times 7i plus 3i times 2 and then plus 3i times -7i. Okay, just use the FOIL method, write it out one by one. And then take care of it. Okay, -35i plus 6i, this is the 9 terms. You can combine it. Remember what's the I square? I square is going to be -1, right? So you're going to plug it in. So final answer, 31 minus 29i. Okay, for the B here, I would use the formula. Remember the formula we talked about on the review? Like A minus B squared equal to A squared minus 2AB plus B squared. Okay, just use the formula A squared plus 2AB plus B squared. So take care of it. And one more time, what is I squared equal to? That's a -1, right? So plug it in. Write it the standard form of complex number. So you should get -9 minus 40i. Okay, this one. And this is gonna be using the formula also, a minus b times a plus b. Okay, that will be equal to a squared minus b squared. So you should get 64i squared, and I squared, that will be -1. So your final answer can be 145. This is only real number, right? Or you could put like the 0, but I don't think it's necessary. You could just keep your final answer 145. Okay, property of complex conjugate. For real numbers a and b, a plus bi times a minus bi, that will be equal to a squared plus b squared. Or you could think about like this example. Okay, when you have a minus b times a plus b, you could get away for your I squared. So think about it. I want to write in the standard form a plus bi, but right now my denominator has the -i here. How can you get out of the -i on the denominator? You could just multiply I over I here. Okay, so I times I, which is going to be -i squared. Right, and then I squared, -i squared, which is going to be +1. So that will be 15i, or you could put 0 plus 15i here. When we want to write in the standard form of complex number, you could think about it just like the rationalize the denominator. We don't want any complex number on the denominator. The only way to get it out, you're gonna multiply by I here, because I squared, there'll be -1. But when you have the binomial two terms on the denominator, what do you want to multiply to get out of the complex number on the denominator? You're gonna multiply the compressed conjugate. Remember the conjugate, like a plus b, the conjugate would be a minus b. Or when you have an a minus b, the conjugate will be a plus b. But now we do have a complex number. So the conjugate of this guy, that will be 3 minus I. So we're gonna times 3 minus I over 3 minus I. And then this one, you could use the formula a plus b times a minus b. On the top here, make sure you guys put the parenthesis, okay? Because you need to use the FOIL method, distribute one by one. So you should got this guy. Combine the 9 terms. At the end. Okay, I'm gonna simplify it. You could factor out the 10 on the top. So you're left with 1 minus 2i, right? 10, parenthesis, 1 minus 2i on the top. So the 10 and 10 you cancel out. So you should get 1 minus 2i here. And this is the form a plus bi. This kind of the question really similar to the review session. The rationalize the conjugate. Okay, you could review it as I remember should be the R7. Okay, simplifying powers of I. You know I squared is gonna be equal to -1. I to the power of 4. We could break it down like this. This is the exponents. 2 times 2, you're gonna get the 4 here. And you know I squared, that's equal to -1. And -1 squared, that's gonna be equal to +1. Okay, right? And then so if it the powers of I, so you know I to the power of 1 is also equal to I squared, you know this is gonna be -1. I to the power 3, that will be equal to -I. Don't try to memorize it, okay? Let me show you guys how to do it. You know I is gonna be square root of -1, right? So first, I is just equal to I. Okay, I square, I could do square root of -1 times square root of -1. So this is gonna be equal to -1. And then I to the power of 3. I could break it down to I squared times I. Alright, 2 plus 1, the exponent, that is going to be equal to 3. And then you know I squared, which is going to be -1. And I still keep the I here. So -I. Okay, same idea, I to the power of 4. I could do I squared times I squared, which is going to be -1 times -1, which is going to be +1. Okay, right? So keep working on it. Now I'm going to do I to the power of 5. I could break it down I to the power of 4 times I. You know this guy from here, that's going to be equal to 1. So I only have a I here. I to the power of 6, that will be, you could take advantage of this guy. I have I times I to the power of 5. Right? 5 plus 1, you're going to get the 6 here. And you know, this is going to be I also. I 5 is going to be equal to I. So multiply it, I'm going to get I squared, which is going to be -1. Okay, or let me show you another easy one. I could do I squared to the power of 3. Okay, I squared, which is going to be -1. to the power of 3 still equal to -1. Okay, right? I to the power of 7, I can do I 1 times I 6 here. Okay, so I to the power of 6 is going to be -1. So I have negative I. And then last one, I to the power of x, I could do I square to the power of 4. I square, which is going to be -1 to the power of 4, that will become +1. You could see that's a pattern though. From 1 to the 4, that's a I, -1, -I, +1. Same idea from 5, 6, 7, 8 here also. I, -1, -I, and +1. So they're gonna keep the pattern. Okay, you're gonna see. So 9, 10, 11, 12, that will be exactly the same thing here. Don't memorize it. I would rather you guys just write it on the paper, do it by yourself. Okay, try to understand this concept. Okay, simplify. Simplify each power of I here. So we try to make it like to even number because we know when you have an even number here, either it's going to be -1 or +1. So when you have the odd number, 33, that will be the odd number. First, we're going to bring it 1 out. Okay, take out 1 of the I. So that's going to be 32, which is going to be even number. Okay. And they put it like 4 times x. That will be 32 here. And you know I to the power of 4 is going to be +1. Oh, I think they forgot the I in here. Okay, they're supposed to keep the I here. So that will be equal to I. Okay? Okay, this one. I to the power of -14. This is an even number. So we could do... this is how they do though, but I think it's too complicated. Let me show you guys my method for this one. Okay, for me, for I, -14, first, I'm gonna take care of the negative exponent. So I have a 1 over I, 14 here. Okay, right? Remember the formula a to the power of -1, that's equal to 1 over a. Same idea. Okay, and this is an even number, so this is good. I will make it like square. 7 times 2 equal to 14. And I know I squared, that will be equal to -1 to the power of 7. And this is an odd number, so I still have a negative number here. All right, so 1 divided by -1, which is going to be -1. Okay, same idea for this one, 33. I usually make it like the even number. So get a 1 of the I. And then 32, I still using I square. And this is going to be times 16. All right, times I. Okay, and then I square is going to be -1 times I. And even number, the negative going to be goes away, so I only have I here. Okay, right? The trick is try to make it like even number and use I square. Okay, so make sure these two number, multiply it, you're going to get this guy. Okay, that's it.